Hi, and welcome to a new course tutorial from Level Up Networks. Today we're going to speak a little bit about some basic networking troubleshooting methods that we can do simple from Windows 10 through the command prompt. Today the topics are going to be the following: Ipconfig, ping, NSLOOKUP, and Traceroute. Right, so let's get started. So the first thing I would like to tell you about is one of the commands which is probably most used when it comes to network troubleshooting, and that is ipconfig. Ipconfig is simply a command which will gather information and display everything relevant to the IP address, to the DNS server, to see if a Dhcp is enabled or not, if you're using a static IP, for example. And it will also display information about your DNS servers, gateway, things like that. It's also very, very convenient to, for example, to flush DNS. Let's say, for example, you did a DNS change on your domain controller or on your DNS server, and this has not propagated across your network. So when you flush it, essentially it just renews that DNS list time and tries to find the correct source of the DNS server. But let's not get over our heads. Let's just go for the basic commands with the ipconfig command. And to do this, we will go to the start menu, which is the first little squares on the bottom of your screen, and you then type cmd, which will then display the command prompt. I do apologize, my virtual computer is a bit slow at the moment, but here we go. So that's the command prompt, and let's open it. So once it opens, you will be presented with what I like to call the black box to my users, and from here you can type all the DOS command prompts that were one-time used back in the days. So as I said, we're going to start with ipconfig. So if we just type ipconfig on its own, you will see that it gives us very basic information. Now, it tells us which adapter we are using. So essentially, this is where in this case, it's the Ethernet adapter, which essentially is just the physical cable that's plugged into the back of your machine, into the network port, and that will either go to, for example, if you're in office, it may go to a floor or wall port. It may go straight to your router, for example. And if I had Wi-Fi, we would have another one which would say the Wi-Fi adapter. But I'll show you more about that in a minute. So the basic information here is that it tells us the DNS suffix of our network. Obviously, this machine is not connected to a domain of any sorts, so it's just a very basic home network. So this is essentially just the host name of my network. Then we have the IPv6, but we're going to concentrate mostly on the IPv4, which is essentially the most common, and it's going to become legacy in a few years probably, but this is the most common form of IP address. Now, here the IPv4 address shows us the different connectors. So we have the actual IP address, we have the subnet mask, and the default gateway. Now, the default gateway essentially is your actual router. So this is the machine that is, for lack of a better word, the gate towards the internet, or the door towards the internet. So everything after this gateway is the internet. Now, if we want to see a bit more information about our network, that's very simple. Let me just clear this really quickly. So we use, once again, ipconfig. And in this case, we put a space and then we go /all. Now this will give us a bit more information, as you can see. Let me just maximize it so we can get a good look. So once again, we are presented with the same information we had before, which is the DNS suffix, our IP address, our gateway, and also our subnet. But as you can see, there's a much more information here. So here it tells us the host name, which is essentially the name of our current computer. And then we have here in description, this is the name of the Ethernet adapter that we're using. In this case, it's a virtual one, but hence we have this name. This is the MAC address, which can come in handy if you want to set up, for example, a static IP through your DHCP server. It will ask you for your MAC address. So this will tell you the MAC address of your particular card. Now bear in mind that MAC addresses are unique, so every single device will have a different one. In this case, this one's mine. It also tells us if we have DHCP, which DHCP is essentially, it can be controlled through various ways. It can be controlled through your server, or it can be controlled by your router. Now essentially what this means is that the router and or server will automatically give you an IP address instead of you having to manually set it for your particular device. Once again, we have the IP address and the subnets. This is when the lease was obtained. So as you can see, I just rebooted my machine about a few minutes ago. So I was given this IP address 8 minutes ago. And then it tells you roughly when it expires. So as you can see, I have it set up that it expires in 24 hours. So what does that mean? That in 24 hours, this IP address may not be the same. It might, if we restart our machine a few minutes before and then come in tomorrow around 5 o'clock in the afternoon, we may get the same IP address, don't get me wrong, it just depends which one's available, but there may be that we don't get this one. Now, this doesn't really make a difference. As long as there's enough IP address in your configuration, you'll just get the next one available. Here's your default gateway. As I mentioned, this is the router. In this case, because I don't have a server, it's all managed through my virtual environment, the DHCP server is exactly the same as the gateway. This is not always the case. If you have, once again, the server and you have also a router, you may want to configure your DHCP through the server and just use your router just for that, just for the internet, which in this case, that would mean that the gateway would be the router and the DHCP server will be, for example, your domain controller. Now, something very handy here as well is the DNS server. So the DNS essentially is, I don't want to get too much into it, but essentially is what gives you your name resolution. So for example, if you have other machines in your domain, you can call them, instead of calling them through the IP address, I can call this level up PC, for example, and then if I ping level up PC, we'll get to the ping in a minute, it will, if it's in your DNS server, it will find that. Now in this case, my DNS servers are my external IPs, so internally that will not be too handy. It won't be able to resolve it, so I would have to also add my domain controller or my DNS server as part of my DNS servers in order to be able to locate that. That's pretty much the basic configuration that Ipconfig has. Now, there's a few other features in this. So to see all the available switches, let's have a look at them. So we go ipconfig space / ? Now, we've already tried the first one, as you can see here, which in the options, these are the switches that are available for this particular command. So we're not going to go through all of them. I'm just going to go through a few of them, which are very handy. So the / ? is obviously to get this menu. Now this is pretty much the case for every single command and the command prompt. So as long as you know the commands, you put a space and then / ? And it will display this menu with all the information and the available switches, and it will show you a few examples, as you can see in the bottom here, over here. We also just previously used the / all, which is the one that shows you the full configuration for all your networking information. But the ones we're going to use a lot are / release, / renew, and flush DNS, and finally register DNS. Now, let's say, for example, you are having some issues in your network and you're not able to ping your server, Now this could very well be because, I don't know, your your server got restarted and you left your machine on, and your machine did not get a new IP address when the server came back up. That's usually pretty easy. The first thing you would probably try is just to renew your IP address. So you just type ipconfig and you /renew. And it will go through there. Now, bear in mind, like I said earlier, I don't have a server, so it will probably give me the same IP address, which it has. As you can see, I have the same 10.0.2.15. Now, if this was a different case where we had 50 more computers or even 4 or 5, it could potentially be that we get an IP address in a different ending. Now, let's say, for example, this doesn't work. So we want to do some further troubleshooting, or so we would use, for example, the ipconfig release. Now, the ipconfig release is pretty simple. What it does, it essentially removes your IP address and removes you completely from the network. So if I go release, okay, you can see now that I can't find my host, doesn't find my gateway, and here in the bottom, the little icon of the networking has gone to, there's no internet access and no internet. Now let's verify that. To do this, we just type ipconfig again. And as you can see, it's giving us an IP address, which is just our loopback for the IPv6, and it's also giving us this IP address, 169.254.38.46. Now don't get confused. This is an IP address, but that doesn't mean you're on the network. So this 169, etc., etc., is what's called a loopback. Now, a loopback is just a default IP address the machine will give you, but that does not constitute any sort of networking. So in order for us to get back on the network and get our IP address again, we will have to use a command that we used previously, which is ipconfig /renew. So let's clear the screen again. We go ipconfig space /renew. Press enter. Now, if there's nothing wrong with your networking, as you can see, it will automatically give you an IP address through your router and or your Dhcp server. So once again, we're back online. Now, let's say, for example, that we want to ping a server or ping another computer, and we're getting some resolution errors. So essentially, it's giving us that the name cannot be resolved. Now, this could be various reasons. This could be because, like I said earlier, your DNS server is not configured correctly, or maybe you're not grabbing the correct details from the server itself because you rebooted it. But let's say that everything is okay with your computer, with your server, but for some reason, DNS is not resolving. So this is when you would use the flush DNS. Now, it's very simple to use. Once again, ipconfig space /flush DNS and press enter. Now, as you can see here, it's telling us that it has flush. So if, for example, you had some erroneous cached DNS. So for example, you set up in your host file an IP address and it was routing to another domain, and you realized that that was wrong, or you had something in your DNS server and you essentially made a change, so and that has not propagated. So what this command will do with the flush DNS is that it will go to your pre-configured DNS servers and it will download really quickly all that information in order to be able to find those DNS settings. So once again, let's try ipconfig /all, and it should be all perfect as before. So we got our DNS servers again, gateway, we have our Dhcp server, obviously an IP address. Okay, so that's all for ipconfig. Let's go for the next one. Ping. What is a ping? Essentially, a ping is when your computer is trying to send a packet or a little tiny bit of information to another computer and it wants to see if it gets a response. It's essentially like saying hello and it wants to get a hello back, okay? Like back in the good old days of terminals. In order to use the ping command, it's very simple. You can just type ping, P-I-N-G, H, ping, space, and here you can do either a domain name or you can also do an IP address. Now be careful when you use domain names, because if you don't have your DNS settings correctly set, it will not resolve those domain names with a valid IP address, and it will just give you wrong information that it cannot be resolved. So you may have internet, but you may be trying to ping a website that doesn't exist, for example, and obviously that's going to give you an error. And if you think that website exists, then you may cause you more issues in your troubleshooting, thinking that everything is fine or that something is wrong. So let's try to ping Google's DNS. Now, there are many IP addresses for Google, as you know, but one of the most common used is the 4.8 with 3 dots. So let's proceed with that. So we have ping there. So let's type now 8.8.8.8.8. So that's one of DNS servers from Google. And actually, let me write that back because I put CLS instead of anything else. So ping 8.8.8.8. Press enter. So by default, what this is going to do is going to send 4 packets, okay? Hence why we have 4 replies. And it's going to tell us how many of those packets were received and tell us how long it took us to get that hello back. So let's examine this a bit. So as I said before, we're pinging one of the DNS servers from Google, which is the 4.8. So we sent the 32 bytes of data, okay? So we got a reply, and it took 27 milliseconds to come back. Now, on average, you don't want to get anything over double digits. So if it's taking longer than double digits, that could just mean that either the server that you sent the ping request to is extremely slow, or there may be something wrong with your connection. It might be that you're having some noise in your line. It could be that your broadband or ADSL connection is just too slow, so it's taking a bit longer. So anything within 2 digits, maybe the lower 3 digits, like hundreds, are okay. But anything over that, then I would have a check on your networking. You might have, like I said, a faulty line, or you might have a very old network cable that is causing interference, or you might have your mobile phone next to your computer might be connected, or a microwave might be doing interference with your cabling, and hence is causing slower connections. Now, okay, so we got 4 replies, but let's say, for example, that we want to send a ping request. We want to leave it running there for you until you go to your router and you plug it in. And instead of you going to the router, coming all the way back, oh my God, it's not working, type ping again. We're going to do a command now, which is going to do a continuous ping. So for this, it's just ping -t and the desired IP address. So once again, let's ping Google. So as you can see, it replies, and oh, it's doing more now. So yeah, this will continue until you stop it. So as you can see, it varies from time to time. Sometimes it takes 28 milliseconds, 27, 31, but that's within reason. It's normal. There's things going on in the background on both your computer, on your line, on the provider, Google. So as long as, like I said, it's low as it is now, that's absolutely fine. Now, what is this handy for? As I said before, this is very handy to see, for example, let's say, for example, your system administrator is working on your website, okay? And they're doing some changes, and you want to ensure that it's going up. You start pinging your website, and you see that it's down. So you send an email to all your customers saying, please bear with us, the website's down, we'll let you know when it's back up, okay? But that IT developer is extremely busy, so he's just going to put it up, and he's going to forget to call you to let you know it's up, so you're going to be waiting. Well, not with this. So with this, you just set the ping, you call your developer, he'll say, I'll get up to it. And when the website's up, you'll start getting these ping replies without him even having to notify you. Another example would be, for example, let's say you are monitoring one of your customers' internet line and you want to get notified, or you want to know, not notified, but you want to know if the internet's down. So with this, you can do a ping request and you can see if their ping is up or down. So to stop this, you just press Ctrl+C on your keyboard and you will get the summary as you have here before. So as you can see, we sent 95 packets. We received 95 of them. Hence, it's a perfect connection. Now let's see what happens when we type to an IP address that doesn't exist. How would it show us? So I'm going to put something that is not on my network. So 192.168.12.2, for example. Just a random IP address. So as you can see, it's taking a bit longer, and we're getting here a request timeout. So essentially what that means is that that machine is not responding. Hence, it's timing out. Now this is ideal to see if your networking or that particular machine you're troubleshooting is online or not. So when you deal with a customer, they tell you, oh, you know what, I'm having issues, I don't know, connecting to the internet. You can tell them, for example, well, why don't you ping Google? So you tell them ping and space 8.8.8.8. And if they tell you that request timeouts, then that either means they don't have internet, or there's something with their DNS, or it could also be that particular server is down. But it's doubtful that Google will be down. Another handy command, excuse me, another handy command within ping is the -a command, switch, sorry. So what does this do? So the -a will resolve the IP address into a host name, so a complete domain, and it will tell you what you're looking at. Now, don't get me wrong, it doesn't always work, but a lot of the times it does. So let's try to see if it works with Google and see if it gives us any response back. And there you go. See, by putting -a, it tells us it's pinging dns.google, okay, and the IP address, blah, blah, blah. So let's see again, just so you can compare both of them. If I don't put the switch -a, it will just tell us that we are pinging the IP address. So it's very handy as well. This is handy in the sense, let's say, for example, I don't know, you get a report from your website that this IP address is trying to do a hack into your website. So you want to see where this IP address is coming from. Maybe it's someone you know, maybe it's in a different country. It's just handy information. It's not, maybe in that example particular, it's not something you would particularly use, but it just shows you how to use this. Perfect. Now, once again, if you want more information on how to use ping, all we have to do is, like as we did with the Ipconfig, is ping space / question mark. And once again, here you have all the different switches. So we used -t already, and we used -a. But you can see there's many more you can use here. So for example, another handy one here is a -4, -6. When would you use it? Well, sometimes when you ping a more modern machine, it will give you the IPv6, which for most of us is just completely gibberish and useless when it comes to troubleshooting. So you want to enforce that, or ensure that you get the IPv4, which is the 10.0.2.2, for example, formats of an IP address. So what you would do there is just you would go ping -4, let's say google.com. And there you go. We get, as you can see, with an IPv4 response. Obviously, it would probably work without it in this case. It does, but there are some machines that it will just give you the IPv6, and you have to put the -4 in order to get this going. Okay. So the next one in our list is NSLOOKUP. Now NSLOOKUp is very, very handy. NSLOOKUP will essentially do a lookup, sorry for the redundancy of the word there, to a domain. It will tell us if it found it or not, and it will also tell us where it was found from. So essentially, it will give you your hostname and the external IP address of your configuration or of your network, and see if it found it. So let's say, for example, NSLOOKUP google.com. So, as you can see here, well, I'm using a private VPN, so my IP address, my external IP address is hidden because I'm using a VPN. But in this case, it gave me the following information. So it's saying the server, which is resolver1.privateinternetaccess.com with my external IP, that's my internal external IP, let's say, and was able to find Google with this particular IP address. Now, why would you do this? Very simple. So this is, once again, to ensure that there's no issue in your networking in resolving domains. Let's say, for example, you want to check your Exchange server to see if it's accessible from your house, maybe because you're not getting emails. With this NSLOOKUP, you would put essentially the full qualified domain of your Exchange server. It will tell you what it's using to get that information, and if it finds it, it will give you the name and the correct IP address. If one of these two is missing, then there's something wrong either on your side or potentially on the server you are trying to, or domain that you're trying to find out. Okay. This is very handy, like I said, once again, just to see if there's any sort of external issues that are preventing you to reach a certain location on the internet. Once again, let's do the /? to find all the usages. So as you can see here, there's no switches for it. You would use it only with the host or the server in case you're looking to do those type of things. Now, the final thing I want to show you today is TRACERT. Now, TRACERT is a very powerful one, and it's very informative. So essentially, just like the word says, it's tracing the routes. So what that means is that it's picking up from your computer how many machines it's hitting before it reaches a destination. Now, those are called hops. So let's say, for example, once again, Traceroute. But in this case, let's not do google.com because we've used it too many. Let's see how long or how many different machines or how many different IP addresses or how many hops it reaches my website. So we go levelupnetworks.com. So trace RT, which is Traceroute, space, and the full qualified domain. Press enter. Right. So in this case, it didn't work. Let's see if we tried www. There we go. So that was my bad. Sorry. So right now it's going to go trying to find the www.levelupnetworks.com with the IP address 79.170.44.117. So it starts off locally. This is my IP address. Okay. Then it goes to the, because I'm using a virtual environment, this will be the virtual gateway. Then this is going to my VPN provider, and then it's going through the different hops or the different IP addresses to get to the actual destination. Now, as you can see, it doesn't find every hop. Now, that can usually mean because there is either a networking issue between this machine and the next assumed hop. Excuse me. It could mean that this machine is just blocking any sort of ping back information. But in that case, let's wait. Okay. We'll just wait till it finishes. This is not usually the quickest thing, but it's very handy. Once again, One example for this would be for you to check your Exchange server, for example. So you're at home, you're not getting emails, and you want to check if you can reach your Exchange server. Or, for example, let's say that emails are extremely lagged, they're taking, minutes instead of seconds. Well, it could be potentially because of something like this. It could be that one of the hops is down, one of the hops is delayed, or it's just, there's something wrong with your actual server. This could be very well, once again, that there could be something wrong on the hop itself. Okay, I don't want to bore you, but let's try another one otherwise. Okay, so essentially when I stopped it, it actually found the next one. It was going to continue. So yeah, essentially we've gone through more hops until they reached the server where this is hosted. Okay. For Traceroute, that's pretty much it. It's basically just another tool, as it was the previous one of NSLOOKUP, to check for external issues instead of internally. But I would always recommend first to double check internally, make sure everything's fine, because we always usually, it doesn't make sense, but we usually try to blame third parties instead of looking inside. We can, a user tells us, "Oh, I can't reach the email." "Oh, that's because your internet's down," or because your provider is doing something. Well, no, it's not always the case. Most of the times, it's something gone wrong on the server. There's something wrong with your networking. It could be that your internet is not working correctly. Okay, so that's really all for now. I hope you found this tutorial useful, and we'll definitely be back with more of them for you. To get the latest tutorials, don't forget to subscribe to our channel. Until then, take care.